Now, since we have a reference to the function object, we can call that just like we normally would call the function. The difference being, instead of calling it by name, we're using this func variable. So we can simply return func, and then we're going to use the same calling notation, unpacking our args that were passed in, as well as our keyword arguments. Welcome back to Understanding Python. My name is Jake, and today I'll be talking about functions. Functions are something you'll be writing a lot in your time as a Python programmer. They allow you to separate and package logic into chunks of code you can call in other places. If you find yourself writing the same lines over and over again, then you'll likely want to separate that into a function. Understanding and mastering functions are essential to a Python programmer. So let's jump right in. Let's get familiar with the syntax of a function by using a basic example. We'll put in def hello. And then in this function, we're going to print hello world. So let's look at each piece of this. Def means define. So you're defining a function. And the name of that function is hello. The open and close parentheses after hello is where you can list out any arguments that your function might accept. In this example, we don't have any, so we leave that blank. After that, we put a colon to let Python know that we're ready to move on to the logic of our function. And the logic of this is simply to print hello world. Now, in order to call this function, all we have to do is type its name, hello, followed by an open and close parenthesis. Again, since this function doesn't take any arguments, we don't have to pass any in for it to run. So we'll save this and run it. And here we see hello world. Easy enough. Now to add another word to our function syntax, we're going to create another function called return hello. Again, we'll start with def or define, and the name will be return hello. This as well doesn't take any arguments, so we can leave that section blank. Instead of printing hello, we will return hello world. Now since this just returns that string hello world, if we want to print this out, we'd have to explicitly print it when we call the function. So we'll print return hello. And again, we're going to leave the parentheses empty as it doesn't accept any arguments. Save this, run it, and we see the exact same thing as we saw above. The difference is, instead of the function itself printing hello world, we're printing what the function is giving back to us, which is hello world. Now I've mentioned arguments a few times already, but what exactly are arguments? Well, let's make a new function. This one will be called hello name. So we'll say def hello underscore name. And in here, it's going to accept an argument called name. And then much like above, we're actually going to have the function itself printed out. We're going to do that with an f string and say hello and then name inside the f string. Now if I were to call the function hello name and pass in name equals Jake, save it and run it, we'll see hello Jake. But what happens if I don't pass in anything? Let's take a look. Oh, we see that it's missing a required positional argument, name, because we're expecting our function to accept an argument called name, but we didn't pass one in. Well, one way to be a bit more friendly with our functions is we can define default values. So for name, we can say name equals world. Now, if we don't pass in a value for name, then it's going to use world. As we now see below, hello Jake, then we didn't pass in anything, and we get hello world. So not only can you specify arguments, which would be name in this case, you can also specify default values for those arguments. And default values are typically a good practice. Continuing on talking about default values, let's create a function now where we specify two arguments, one of which will have a default value. This function will be called multiply. So we'll type def multiply. This will accept two arguments, creatively num1 and num2. And we'll add a default for num2 to be 5. And all this will do is return num1 times num2. Simple. Now let's print out a couple of uses for this. Okay, so for our first example, we're going to be multiplying 5 and 6. And I may have done something in this f string that you haven't seen before. And that is, not only can we print out particular values of a variable, we can evaluate expressions as well. And that expression being calling our multiply function with its argument 5 and then num2 being equal to 6. And then the second time, we're just multiplying 5 by the default, which in this case will be 5. So we'll save this and run it. And now we see at the bottom there, multiplying 5 and 6 equals 30. And then multiplying 5 in default, in this case 5, is equal to 25. But let's try one more example. So I'm going to copy this, and instead of having 5 here, let's say num2 is equal to 7. We'll save it, run it, and here again, although we specified num2, we see that num1, because it doesn't have a default, still gives us that error that we're missing that one required positional argument. So always keep in mind which arguments have a default value and make sure you fulfill them. Now let's add a little bit more into our functions. I'm going to create a function called first and last. And it's going to accept a word. It's not going to have a default value. And what it's going to do is return the first letter of word as well as the last letter of word, because in our functions we can return multiple values. Now if this is a little bit confusing to you or someone else that's watching, we can do something else in our functions. We can create what are known as doc strings. So for our doc strings, we'll use our triple quotes, and inside here at the top line we'll give it a description, return the first and last letters of a word. And then down below, something else you may commonly see is we're going to add a notation for a parameter, that being our argument word. We're going to annotate its type by saying string there, and then a brief description. Can be a word or sentence. Now we've got a function called first and last that accepts a string called word, and our doc string tells us that we're returning the first and last letters of a word. And if we look down here at the return line, we can see word with position 0 and then word with position -1. Which -1, if you remember back to my video on strings, will return the last element of a string. So let's run an example of this. We'll again use an f string, and here say first and last of query UEOP. And then we're just simply going to call first and last and pass in the string query UEOP. We'll save that and run it. And now down here at the very last line, we see first and last of query UEOP is a tuple with the value Q and P. Okay, so that's interesting that it gave us a tuple. It packaged both the return values in technically a single object. If you remember back to my video on variable unpacking, then this won't be as much a surprise to you, and you'll know what to do to unpack those values. But for those who may not have watched that video, first, I highly recommend it. But we'll go ahead and also show you how to handle these. So we'll create two variables. First, comma last is equal to first and last of, and here we'll do the next line on the keyboard. And we'll simply use another f string, say first, mapping to first, and then last, mapping to last. Save it and run. And here we see first is A, last is L. Okay, that wraps up the beginner section of this video. You now know enough to go out and start writing your own functions. Go ahead and experiment with different types of arguments, different types of return values, and let me know how it goes. If you want to progress further, then stick around for the intermediate section. Now to step up into our intermediate section, we're going to work on making our functions a bit more flexible. The first way we're going to do this is through argument packing. And the way we'll demonstrate this is through a new function called addAll. And this is going to take in star nums. So what star nums means is that's going to pack all the positional arguments passed into addAll into a single tuple. And before we build anything else into the function, let's just go ahead and print out nums so we can take a look at it. And call it with 1, 2, and 3, all as positional arguments. Save it, run it, and here we see nums is equal to 1, 2, 3, all in a tuple. So now that we know that nums is a tuple, and then we can iterate over a tuple, we can do different things with it. So for example, if we wanted to add everything together, we can just say count equals 0 for num and nums, count plus equals num, and then finally return count. Now that we're returning count, let's change our addAll line down at line 9 to be a print. Okay, now it's a print statement, kind of tells us what's going on. We'll save and print, and we see adding 1, 2, 3 is equal to 6. And we could have extended this even further, 4 and 5. Running this again, we see that now we have 1 through 5, all added up equals to 15. This way we can write a function that adds everything together without having to specify a set amount of positional arguments. Now, not only can we accept an arbitrary number of positional arguments, we can also accept an arbitrary number of keyword arguments. We'll demonstrate this with a new function called print quarks. And in here, we're going to use the notation ** quarks, or keyword arguments. Got a couple of print statements. First one, just saying you passed in the following keyword arguments. And the second, we're going to go ahead and print out those keyword arguments. And to demonstrate this function, we'll call it print keyword args, and the first thing we'll pass in, say name, put my own name. The next argument we'll put occupation, quality engineer, and then finally company, Red Hat. All right, we'll save this and run it. And you see these bottom two lines, you passed in the following keyword arguments, and we have a dictionary mapping the argument name with the value. So using this ** quargs notation packs up all of the arguments into key value pairs in a dictionary, and from there we can do whatever we want with them. So since this is a dictionary, we can modify this line here and then loop through the dictionary for key value in quargs dot items, and then we can do some string printing, key to key, and then value to value. All right, if we save that, run it again, now we have you pass in the following keyword arguments. Key is name, value is Jake. The next one, the key is occupation, value, quality engineer. And the last one, the key is company, value, Red Hat. Now we didn't have to know the name of any of these arguments ahead of time, but our function is able to process them and we can do whatever we want with them. Also, if someone passes in a keyword argument that we weren't expecting, we can handle that as well, or just simply ignore it. Now to put these two together, we'll make a new function called print all. And it's going to take in star args and star quargs. Then we're going to put a little line up here saying printing arguments. And for arg and args, print argument, map that to arg. And since we already have a print quargs function, we can just simply call that and pass in the quargs. So we'll do print quargs, and then here we're going to use the same star quargs notation, and what that will do is actually unpack the dictionary back into this format. So it's not going to be passing a dictionary into it, it's going to expand it, and then if the function just so happens to accept the star quargs, then it'll pack it back into a dictionary. If not, it'll keep it expanded into the keyword arguments that a function may already expect. Okay, so to demonstrate this, we'll make a couple of data structures. So we'll create a quick list. My list is equal to x squared for x in range 5. Then we'll create a dictionary called myDict, make it equal to explicit casting of the key into a string, and then the value is just going to be the value cubed for x in range 7 to 11. Sure. And then we'll call print all, and we will unpack my list, and we'll also unpack my dict. This way, each of these gets expanded into both positional arguments for my list and keyword arguments for my dict. Save it, run it. And here we have printing arguments 0, 1, 4, 9, 16. And then it calls the print quargs function. And that's also going to print 7 through 11 for the keys, and then those numbers for the values. And for our final example, I'm also going to show how functions themselves are objects within Python. So we can make a new function called execute func. And this is going to take in a function as an argument. We're also going to take in star args and star keyword args, as we don't know what the arguments and the keyword arguments for this function are going to be. So in here, it's going to be a real simple execution. We'll say executing func, and this is going to give us the function object with args, and then we'll print out our arguments, and quargs will be, of course, our quargs. Now, since we have a reference to the function object, we can call that just like we normally would call the function. The difference being, instead of calling it by name, we're using this func variable. So we can simply return func, and then we're going to use the same calling notation, unpacking our args that were passed in, as well as our keyword arguments. So this lets us execute just about any function that can be passed in. And to demonstrate, we'll run this execute func. We're going to pass in the function add all, as well as with some positional arguments 7, 8, and 9. And then we're also going to execute the function print all. And in here, we're going to pass in a mixture of both positional and keyword arguments. So 1, 2, 3. And we'll say A is equal to 4, B 5, C 6. All right, I'll save this and run it. And if we look up here, we see we have executing a function object, add all, and it actually gives us the location in memory where it's at with the arguments 7, 8, and 9 and no keyword arguments. And then we have the function print all, again with its own memory address, and we have our arguments 1, 2, 3, and our keyword arguments being a dictionary, mapping A to 4, B to 5, C to 6, and that goes through its entire process of printing everything out. Alright, that wraps up the intermediate section. With what you know now, you can make a lot more flexible functions within your programs. However, if you want to learn how to lock them down a bit, continue on to the advanced section. Okay, in this advanced section, we're going to be talking about one specific area of function definitions that allow you to be very specific in how you design your API. If you really want to control how other people call your functions, we can use two different patterns or the combination of two different patterns to really fine-tune that control. So for this first function, we're going to call this keyword only. And as you guessed it, this is only going to accept keyword arguments. And the way we do this is before your keywords, you put a star. Then you can put your keyword arguments, A, B, and C. This lets Python know that anything after this star should be keyword only, and it will outright reject anyone trying to use this without keyword arguments. So since we only really care about the argument line, we're simply just going to return A, B, and C. Now the first time that we're going to call this, we're going to call it incorrectly. We're going to say keyword only. And in here, we're going to try to call keyword only with positional arguments 1, 2, 3. Put some spaces. Close that out. All right. If we run this, we're going to get an error. And we see keyword only takes 0 positional arguments, but 3 were given. So that's behaving exactly as expected. And all a user has to do to fix this would be to specify these as keyword arguments. So A equals 1, B equals 2, C equals 3. We'll save this and run it again. And now we have keyword only 1, 2, 3. Now similar to keyword only, one thing that was introduced in Python 3.8 is the ability to specify positional only arguments. So we'll call this one positional only. And here, we're of course going to do A, B, and C again. And the way that we make sure that these are positional only is we put a / after our positional only arguments. Now my editor doesn't like this because I'm still in a Python 3.7 environment. So if you go ahead and switch to a 3.8.2 environment, it's going to stop complaining. And in here, just like above, we're going to return A, B, and then C. Of course, we're going to give the bad example first. So we can actually just go ahead, pretty much copy up here, change from keyword to positional, save it, and run it. And down here we have type error positional only, got some positional only arguments passed as keyword arguments. So it's the exact opposite of before. All we have to do is get rid of the keywords, give it 1, 2, 3, save, run, and here we go. Positional only runs perfectly fine. Now if you wanted to write a really picky function that had a complex mixture of positional, keyword, and more loose arguments, you can do exactly that by mixing the two concepts together. So we'll call this one picky func. We're going to have a positional only argument called name. After that, we're going to have just a regular argument. This could be specified by keyword or position. And after that, we're going to have a keyword only argument called return code. Make that equal to 0 by default, as all good return codes should be. In our line, we're going to print an F string and say I am, and then inside blank if picky, else space not, and say picky, and then the name, of course, with an exclamation point. So it's going to say I am picky or I am not picky, depending on the value of picky. And then we're finally going to return the return code. Now to give the bad example, we're going to go ahead and print this out. So picky, and we're going to call picky func with name equals Jake, which we know that that is not going to work because that is a positional only argument. Picky equals false, return code equals 1. Now if we save this and run it, we're going to get our error because again, got some positional only argument passed as a keyword argument. If we remove that as a keyword argument, save it, run it, everything works perfectly. I am not picky, Jake. There's many more complex things you can do with functions. However, I consider them to be more appropriately covered within other subjects. So that wraps up this advanced section. Thanks for sticking with me. And that also wraps up this video. Now that you understand functions, take a look at your code and figure out what should be separated into a function. What is your favorite trick with functions? Or was it something I showed today? Leave a comment down below to let me know. As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, leave a comment for me. To keep up with this series, please consider subscribing. Thanks for watching.